Welcome to the mathematics in my channel. Today we are going to solve another interesting indefinite integral of inverse hyperbolic tan of x over x dx. Well, how to begin? Okay, first we should know about inverse hyperbolic function formula. So if we take, first I am going to take inverse hyperbolic sine of x. We know the formula. We can write this is equal to natural log of x plus x square plus 1. Okay, and then if we take inverse hyperbolic cosine of x, we know inverse hyperbolic cosine of x, we can write this is equal to natural log of x plus x square minus 1. Then if we take inverse hyperbolic tangent of x, we can write this is equal to 1/2 natural log of 1 plus x over 1 minus x. Okay, now this is important formula for this question. So now I'm going to plug in instead of hyperbolic inverse hyperbolic tangent of x, we can write now this is equal to here 1/2. So 1/2 we can write outside of the integral sign, and 1/2 natural log of 1 plus x over 1 minus x over here x dx. Okay, now we know this property of natural log. So natural log of b over a, we can write this is equal to natural log of b minus natural log of a. So we can write our integral is equal to now 1/2 natural log of 1 plus x over x dx, then minus 1/2 integral of natural log of 1 minus x over x dx. Well, now I'm going to take this part is equal to I1 and this part is equal to I2. Okay, now I'm going to take I1 and try to evaluate I1. So we know I1 is equal to 1/2 natural log of 1 plus x over x dx. Okay, then we know the expansion of natural log of 1 plus x. We can write a series. We can write natural log of 1 plus x is equal to infinite sum. So n is equal 1 to infinity minus 1 to the n plus 1 times x to the n over n. Okay, so now we can plug in here. Now this is equal to 1/2 integral of infinite sum n is equal 1 to infinity. Now here minus 1 to the n plus 1 over n times x to the n, and here also we have x, so x dx. Okay, then we can simplify. Now we can switch the integral sign and infinite sum. So we can write 1/2 infinite sum n is equal 1 to infinity minus 1 to the n plus 1 power over n integral of now x to the n here over x, so x to the n minus 1 times dx. Okay, now we can integrate and we can write here 1/2 infinite sum n is equal 1 to infinity minus 1 to the n plus 1 power over n, and here if we integrate x to the n minus 1, we know x to the n over n plus c1. Okay, then we can write now I1 is equal to 1/2 infinite sum n is equal 1 to infinity, and here now minus 1 to the n plus 1 power, minus 1 to the n plus 1 power, and here x to the n. So now I am going to divide and multiply by minus 1 to the n. So we can write here minus x to the n, and we should divide it by minus 1 to the n. So minus 1 to the n, and here n times n, so n square plus c1. Now we know this minus 1 to the n and this minus 1 to the n get cancelled, and here we will have minus 1 to the 1. So minus 1 to the 1 we know always minus. So here now minus 1 half infinite sum n is equal 1 to infinity. Now here we have minus x to the n power over n square plus c1. Okay, now we know about logarithm function. So we know logarithm of c is equal to infinite sum k is equal 1 to infinity z to the k over k square. Okay, now we can use this formula. So we can write now this is equal to I1 is equal to minus 1 half. Now instead of this part we can write the logarithm of minus x plus c1. Okay, now we evaluated I1, and then we should evaluate I2. Okay, now we are moving to I2. So I2 is equal to, now I2 is equal to, we know minus 1 half integral of natural log of 1 minus x over x dx. Okay, now here minus 1 half integral sign. Now instead of natural log of 1 minus x we can use similar series, but here minus x. So we can write now infinite sum n is equal 1 to infinity minus 1 to the n plus 1 power over n times minus x to the n power over here x dx. Okay, then we can write now minus 1 half integral of here infinite sum n is equal 1 to infinity. Now here minus 1 to the n plus 1 power, and here minus 1 to the n x to the n. So we can write minus 1 to the n times x to the n over n times x dx. Okay, then we can write this infinite sum outside of the integral sign. We can switch. So minus 1 half infinite sum n is equal 1 to infinity. Now here minus 1 to the n plus 1 minus 1 to the n, so minus 1 to the 2n plus 1 over n times integral of here x to the n here over x, so x to the n minus 1 dx. Okay, then here minus 1 half, and here minus 1 to the 2n plus 1. We know minus 1 to the 2n is always even, but 2n plus 1 always odd. So we will have minus sign. So here minus, so we know plus. So here now 1 half infinite sum n is equal 1 to infinity 1 over n, and if you integrate this we know x to the n over n plus c2. Okay, then we can write now this is equal to 1 half infinite sum n is equal 1 to infinity x to the n over n square plus c2. Now we know this is equal to 1 half t logarithm of x plus c2. Okay, now we know this is I2. Now we evaluated I1, and also I2. So we know now I is equal to I is equal to I1 minus I2, I1 minus I2, and I1 we know minus 1/2. So here this is I2, so we can write 1/2 the logarithm function of x minus 1/2 the logarithm of minus x. Now instead of c1 and c2 we can take c. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.